Okay, good morning all of you. Yesterday we spoke at autocatalysis. Under autocatalysis, I have written second equation. Once you check it, what is that one? 2 moles of the which one? KMnO4 na? KMnO4 plus 3 moles of the H2SO4 and 5 moles of the oxalic acid. Together is involved in the chemical reaction. We are getting some of the chemicals. We are getting like potassium sulfate and manganese sulfate. We are getting 2 moles of the manganese sulfate. Yes or no? Plus I think 10 moles of the CO2 we are getting. Plus I think 8 moles of H2O we are getting. Yesterday I told one small mistake. Please you correct that one. I told K2SO4 is acting as a autocatalyst. No. Instead of that one, manganese sulfate is acting as a autocatalyst. You correct that point. Okay, why? Because from manganese sulfate, what ion is coming? Mn plus 2 ion is coming. You know very well. Mn plus 2 is the d block element. That too having so much special. Why? Because having incomplete filled configuration in d orbital. Due to that reason, this ion is acting as a catalyst. Please correct that one. Manganese sulfate is acting as a autocatalyst but not potassium sulfate. We will go to further concept. Okay, already I think we discussed one farmer's question, physical absorption, chemical absorption. One more farmer's question I am explaining. Very easy and very clear question. You see this one. Mechanism. Again, one more farmer's question it is. Mechanism of heterogeneous catalysis. Heterogeneous catalysis. See what I am explaining as it is later on, you will get very easily 5 marks. See first of all, how heterogeneous catalysis will be going on. Did you remember in adsorption application we studied this point, and yesterday we learned about what is the heterogeneous catalysis. Together we will see all these points. First of all, we have to discuss about the heterogeneous catalysis. Heterogeneous catalysis. As you have idea regarding this one. What is the meaning of heterogeneous catalysis? Yes, reacting substance and catalyst should be in different phases. Finally, the whole reaction mixture will be heterogeneous, or more than one physical state will be existing. Okay, that's what I am writing here. See, reactants will be there. Those reactants are in gas phase. Okay, na? And we are taking compulsory catalyst. The catalyst I am taking in solid phase. We have to write on everything, and we are getting products. Those also appears in gas phase. Such catalysis reaction is calling as heterogeneous catalysis. Okay, observe very carefully. Next point, I am explaining about the solid catalyst. Do you have any idea regarding the solid catalyst? Yes, you see carefully. We are discussing about the solid catalyst means is nothing but solid substance will be there at the basic of adsorption we studied. On the surface of the solid matter, some unbalanced force of attraction will be appears. Those unbalanced force of attraction regions only we are calling as active centers or active sites. Did you got it or no? Means you take a solid catalyst, whatever it is, on its surface some unbalanced force of attraction will be there. Those only favorable for the adsorption phenomena that I am explaining now. You see carefully. On the solid surface of the solid catalyst, we have some unbalanced force of attraction regions will be there. For example, like this will be there. This is a solid matter. On the surface of the solid matter, I am showing those active centers. These zeros means what? Holes or nothing but porous, nothing but active centers or active sites. Active centers or nothing but active sites. Those only, there only what happening? There only what happening? Very good, Amma. There only which phenomena is going on? Adsorption will be going on. That is a special. Because these active sites or active centers means what? Those regions are having an unbalanced force of attraction or residual force of attraction will be there. That's why they are always ready to catch something on it. Okay. Now, how to take a chemical reaction is nothing but reactants we have to take first of all gaseous reactants. gaseous reactants has to be sent onto the surface of a solid catalyst, then they are undergoing which one? Adsorption. Then they are undergoing adsorption. How it is, I am explaining, you see carefully. Okay, do you got my point? Gaseous reactant materials we are sending onto the surface of the solid catalyst like this. For example, you are taking a solid catalyst. Onto the solid catalyst I am sending reacting particle. They are in which phase? Gas phase. Definitely what happening? This gas particle will be sticked at the active sites on the surface of the catalyst. That phenomena only nothing but adsorption. How it is happening I am showing here, see carefully. For example, you take here, what is that one? Solid catalyst we have to take. Already we know on the surface of the solid catalyst some active centers or active sites will be there like this. Okay na? Yes. On to this one, what you are sending? A gaseous reactants you are sending. Those gaseous reactants is nothing but A and B. Okay, whenever you are sending those gaseous reactant onto the surface of the catalyst, where they are sticking? They are sticking at the active centers or active sites on the surface of the catalyst. Okay, then what we are getting? You see carefully. You have solid catalyst will be as it is onto the surface of the solid catalyst. Which particle is undergoing sticking? AB particle. Through which phenomena it is going on? It is going through which phenomena? Adsorption. Adsorption means, is it exothermic or endothermic? Exothermic means energy will be releasing. That releasing energy only useful as a activation energy. After sticking of these gas particle on the solid surface, compulsory some amount of energy will be releasing. That releasing energy is taken by again reactant and going into activated state. In the activated state with higher energy they are undergoing effective collisions. Then they will be converting into products. See the phenomena. Understand the concept. Yes, very clear. Due to adsorption we are getting some energy from the process. That energy is utilized as a activation energy. Then the reactants are going into higher energy. Then they are involving in the effective collisions and they are converting into products. Again, what happening? They are going into activated state. No, then they are forming one of the transition compound is forming. Do you know what is the meaning of transition compound? Intermediate compound. Intermediate compound means what? In the middle of the process it will be forming and consuming. Okay, how is this one? After taking this energy, these two particles are involving in the effective collision. We are getting some unstable compound we are getting. I am showing that one also. You see carefully like this. Like this will be there. Between A and B, the bond will forms. This is unstable. Okay, after that what happening? A, B are very close together on the surface of the catalyst. They will be combined together and they combine together with higher energy. Definitely they are converting into products. After converting into products, which will be coming outside? Products will be coming outside and again catalyst will be as it is. Catalyst will be as it is and which will be coming outside? AB is coming outside as the product. Again we are getting catalyst and products we are getting. The whole phenomena is called as heterogeneous catalysis. Still some other information is there. I will explain here. See here the rate of reaction will be increasing through one process. What is that? Whatever energy will be releasing, that will be acting as a activation energy for whole process. Then all reactants are going into higher energy and easily converting into products. Once products formed, they won't stay on the surface of the catalyst. They will be come outside. Again, the old catalyst will be regenerated. Again, sticking is going on, converting into products. Again, coming outside. Again, attacking, converting. Again, attacking, converting. Is there any consumption of the catalyst? No. Is there any change in the catalyst? No. And here, I want to tell one more point. One more reason will be there why rate of reaction will be increasing. From this point we can tell. Anybody can guess? Okay, imagine this room. Okay, you are taking in this room some reactants, you are taking AB.
Okay, right now in this Dirac area, how many reactants will be there? Very less number of reactants will be there. Why? Reactants or gas, they are well separated. Are you getting on? Now what I did, I provided one solid catalyst will be here. What they are doing? What they are doing? All reactant will be coming onto the surface of the catalyst. Then in this unit area, number of reacting particle will be increasing. That number of particle only calling as concentration. As the concentration is increasing, rate of reaction is increasing according to law of mass action. Are you getting on? Best example I will tell. For example, you take 10 ants in this room left. What happening? They are going somewhere. But you taken in this area. In this area, we can identify either one ant or two ants. But what I did, like a catalyst, I kept some sugar here. What happens? All ants will be coming in this region. In this region, what happening? Concentration of the ants, nothing but number of ants will be increasing. Automatically, process will be affected. Are you getting that? Means that only write down here without catalyst. Without catalyst, what happening? The concentration of the reactant in the mixer will be less. But if you take with catalyst, what happening? All reacting particle will be stick on the surface of the catalyst. No, then automatically in unit area number of reacting particle will be more. Means concentration of the reactant will be high. But according to law of mass action, you know very well, law of mass action. According to law of mass action, we studied in chemical equilibrium as well as recently in chemical kinetics. The rate of reaction is directly proportional to concentration of the reactant. Without catalyst, low concentration, low speed. With the catalyst, concentration of reactant is high, automatically rate is high. These are two reasons. As it is, we have to write out as enough to get the marks. See, first of all, we have to explain heterogeneous catalysis is a catalysis in which reacting mixture or reacting substance and catalyst are in more than one physical state or in different physical state. Finally, we are getting heterogeneous mixture. Such catalysis is calling as a heterogeneous. Let us write down. Here, for my convenience, I am taking reactant is in gaseous phase, catalyst is in solid phase. First of all, I am taking solid catalyst. On the surface of the solid catalyst, some unbalanced force of attraction will be existing. Those unbalanced force of attraction regions or spots only my convenient calling as active sites. Okay, those only favorable for the absorption. Next point, we have to take the gaseous reactant, we have to send it or we have to expose onto the surface of the catalyst. Then what happening? Reacting particle will be sticking on the active sites. Under this process, what happening? Energy will be releasing. The releasing energy is again taken by reactants and going into activated state and converting into products. Once products is formed, they won't stay on the surface of the catalyst. Why? Because they got freedom. They come outside. Again, catalyst will be regenerated. Again, starting process will be going like a cyclic way. And one more reason here, if without catalyst, reacting concentration will be less. With the catalyst, reacting concentration will be more. Why? Yes, you are providing some space for that one. Then all will be sticking on it. Then in unit area, number of reactants is more, then concentration is more. If concentration is more, the rate of reaction will be high. This is the best evidence that catalyst will not consume or will not newly form. And it won't change its composition. Yes, you take it how? As it is, it will be remains fine. This is calling as heterogeneous catalysis mechanism. See, for competitive point of view, I am telling one point here. It is nothing but selectivity. Selectivity. Yes. What is the meaning of selectivity? By saying all these, you may get some clarity here. Anybody? For example, you want to do Haber's process. You have to use only iron as the catalyst. Sir, I will use platinum. Is it work out? No. That's why every reaction has a particular catalyst. Means if you want to proceed that particular reaction, we have to use that particular catalyst only. I will exchange, no use. Are you getting it? And one more thing, in some of the reactions, by changing, very nice point, by changing the catalyst with the same reactants gives different products. Again, this one he asked in this year, JEE mains examination, this point only. Are you understanding? If you want to proceed a particular reaction, you have to use particular chemical always as its catalyst. Full clarity. Means if you want to do Haber's, you have to use iron as a catalyst. If you want to do contact process, you have to use platinum as a catalyst. But what I am telling? By changing the catalyst with the same reactant gives different products. And what is this? You see one, sir. For example, CO plus H2. In presence of copper, we are getting a formaldehyde. It is one of the preservative liquid. You see in biology lab, dead animals and dead plants we are storing in one special liquid, formaldehyde. If you want to preserve the dead bodies for a long time, it is one of the best solvent, formaldehyde. You take a same CO plus 2H2, but already we know water gas shift reaction. Zinc oxide, very good one. Zinc oxide is the catalyst and chromium oxide is the promoter. What we are getting? Methyl alcohol we are getting CH3OH. Same I am taking among CO plus 3H2. In presence of nickel, we are getting different product again. We are getting a CH4 plus H2. What I am telling? Different catalyst with the same reactants giving different products. Sorry sir, how? By changing getting product will be changing. That only we are telling. Selectivity. How it is happening, sir? You see, you are seeing only carbon monoxide and hydrogen only. But in first case, how many moles is consuming? Here 2 moles, here 3 moles. This variation of hydrogen moles is depending upon catalyst. Here, in all these reactions, above catalysts, all are reducing catalyst. What is the meaning of reducing catalyst amount? Yes, sir. In presence of those catalysts, what happening? Reduction will be going on. What is the meaning of reduction? Gaining of hydrogen or addition of hydrogen. Okay, but this copper, whenever used, provide only 1 mole of hydrogen. Okay, if you can use zinc, it will provide 2 moles of hydrogen. If you want still more reduction, you have to use nickel. Okay, that's why among copper, zinc, nickel, what is the best reducing the catalyst? Because it is providing 3 moles of hydrogen. Are you understanding? We are not taking this one, this is coming from catalyst. Okay, the providing number of moles of hydrogen is depending upon nature of the catalyst. According to that one, getting product will be changing. He asked at this point only in this year. Yes, it's a very important point. All of you got it or no? Yes. See, one more thing we are discussing here, it is nothing but enzyme catalysis. Sorry. Before this, we have one more shape-selective catalysis will be there. We studied already in first year. Shape-selective catalysis. This is also very nice concept. I think you got it. You learned in carbon family. Carbon silicon there you learned. Shape-selective catalysis. This year in board examination, 2020 board examination, he asked this question in PV examination. Explain the shape-selective catalysis. In that name only answer is there. Generally, shape-selective catalysis means best chemical is nothing but zeolites. Sir, what is a zeolite? How can you get the zeolite? How it is acting as a catalyst? Everything we will discuss. First of all, we have to take the sand. What is the sand composition? 3-dimensional structure of SiO2 units. Just listen. Okay, 3-dimensional structure means every silicon is surrounded by how many oxygen atoms? 4 oxygen atoms like this. Is it clear? Yes. Sir, every silicon is surrounding with 4 oxygen atoms, but you retain only 2 oxygen atoms. Why like that? Yes. Here, this oxygen is not only belongs to this silicon, it is also belongs to silicon. That's why 1 by 2, 1 by 2, 4 into 1 by 2, 2. According to that, already we discussed that. Let it be. You take sand or silica, we have to take is a three-dimensional structure. In this, we have to do some corrections or modification has to be taken. Means in this silicon structure, some of the silicon atoms, right down here, some of silicon atom is replaced with aluminum. Just for understanding, I am replacing one silicon atom. What will happen? I want to study. Yes, you see, remaining silicon, no problem. Silicon here, oxygen, furtherly correction will be going on. Oxygen here going on, but here what is coming? Aluminum, here oxygen, here oxygen, here oxygen. But after replacing aluminum with silicon with aluminum, what changes is coming in the material? Actually, silicon is which charge amount? +4. But aluminum is how much charge amount? +3 only. Which is dominating here? 4 minus 1, no. Here -4 + 4, 0. But here -1, -1, -1, -1, -4. -4 + 3. -1. So, the whole material is acting as a negatively charged material. The charged particle is always dangerous. They are highly unstable because having highly energy, that's why always they are trying for chemical reaction. To becoming neutralized, to this we are adding some of the positively charged particle we are adding like sodium or potassium or calcium we are adding. What they are doing? They will neutralize that negatively charged particle. So what is the name of this one? So this is only we are calling as zeolites. What is the chemical name of zeolites? Is a sodium or potassium or calcium salt of basically silicate. No, in that we introduced aluminum. That's why we are calling as salt of aluminosilicates. Aluminosilicates. This is the chemical name of zeolites. Sodium, or simply we are telling metal salt. Metal salt of aluminosilicates is calling as zeolites. Finally, what we are getting material that will be porous solid. What is the meaning of porous solid? What is the meaning of porous? Nothing but holes, cavities. Okay, means we are getting like this solid material we are getting with so many holes inside it. Okay, those resultant materials only we are calling as honeycomb-like structure. Did you got it? Honeycomb-like structures, those zeolites. Yes, those are acting as a now catalyst for some chemical reaction, especially in petroleum industry. Are you getting up? These whole things will be going on. Finally, we are getting like a solid porous material. We are getting inside so many holes will be there. We are catching that holes and using like a catalyst. Okay, just I will tell you one thing here. We are taking one chemical reaction reactants and I am taking zeolites as the catalyst. We are getting products. See very carefully what happening here. How it is useful as a catalyst. First of all, zeolite will be there. Zeolite means just now I told no. It is nothing but like holes having solid material. Okay, now we are taking reactants. What happening? Condition will be there. Here holes is small, but you are taking a big reacting molecule will not work out. Here holes or big reacting particles is small, will enter and come outside. No use of that one. Condition is what? The size and shape of the reactant should be same as holes present in the catalyst. Then only those reacting particles will fit into that holes. So automatically what happening? Adsorption is going on. No chemical reaction, just going and sitting physically. Under adsorption what happening? Energy will be releasing. Enough. The releasing energy is acting as a activation energy. With that activation energy, the reacting particle going into higher energy state. There they are undergoing effective collisions and converting into products. Once products formation is happened, they won't stay inside the catalyst. They will come outside. Again, holes will be regenerated. Again, going reactants and coming outside products. Entry, coming outside. The whole process will be going on. Then we are getting which particles? Products we have. Again, catalyst will be regenerated. Again, I am telling one more thing. Here also we can apply law of mass action. Yes, there is no catalyst. Reactants are very far away from each other. The concentration will be less. Then effective collision number will be less between them. Then the rate of reaction will be less. Then what you are doing? You are providing one solid material to that one. Then what happening? Reactants will be going into holes. Going into host means close. Whenever they are very close in unit area, number of reacting particles is more, concentration is more, then what happening there? Effective collision possibility will be more. Then what happening? They are easily converting into products. Are you getting that? And one of the best geolite, especially petroleum industry, we are taking alcohols. Yes, I told this one also in first year. Alcohols will be converting into gasoline products. Gasoline products means indirectly nothing but petroleum related products. Petroleum related products. So here we are using one of the chemical as the catalyst ZSM5. What is the meaning of ZSM5? Z means, yes, you know, just now you know, zeolite. S means seal. M means molecular. Zeolite sieve of molecular porosity. Porosity. Porosity means hole. Hole size is how much? 5 microns. Huh? So zeolite sieve. Sieve means like mesh. Like mesh holes will be there, like that material. And molecular hole size will be how much? 5 microns. So it is one of the best zeolite, especially in petroleum industry, to convert alcohols into gasoline or petroleum products. Did you got it or no? So here condition is what? Why we want this one as a shape selective? The size and shape of reactant should be same as size and shape of holes in the catalyst. So only they will fit and undergoing adsorption, then energy releasing energy used as an activation energy, going into activated state, undergoing effective collisions with high energy, definitely converting into products. Once products is formed, they won't stay inside, they come outside. Again, holes will be regenerated, entry coming outside, entry coming outside. Is there any changes in the catalyst? No. With respect to mass and as well as composition. Clear? Yes. Now, one more concept we are discussing: enzyme catalysis. Enzyme catalysis. Then chemistry in biology you are learning several cases of enzyme catalysis. Do you have any idea? Yes. What is the meaning of enzyme catalysis and where it is happening? What is the process? Everything we will discuss. See, once in living organisms, mean like plants or animals, there something is happening. So many biochemical reactions will be going on. Yes or no? Means in the living bodies like animals and plants, so many biochemical reactions is going on. Biochemical reactions. In those biochemical reactions, what happening? Some of proteins or acts as catalyst. Are you getting or no? And such the proteins which are acting as a catalyst, those would be specially calling as enzymes. Nothing but catalytic proteins. Catalytic proteins are specially calling as enzymes. Means it's not a new word, but among all the protein, which proteins are acting as a specially catalyst, those special catalyzing proteins only we are calling as enzymes. The whole phenomena is calling as enzyme catalysis or biochemical catalysis. Are you getting it? Means in the living organisms like in plants and animals, so many biochemical reactions is going on. In that, some of the proteins are acting as a catalyst. The proteins which are acting as a catalyst, they are specially calling as enzymes, and the whole phenomena is calling as enzyme catalysis or biochemical catalysis. I will give you some of the example. You know so many things. I will explain some other new enzyme catalysis reactions. First of all, you learn in biology, I think, as well as in chemistry also. You see, sucrose. Sucrose is undergoing hydrolysis. Sucrose means what? Sugar, normal sugar. And we are getting two different materials. We are getting one is glucose, another one is fructose. Another one is fructose. Just here, if you want to proceed this one, it is happening in the living organisms. What chemical, what protein has to be used as an enzyme? Yes, invertase. This is important. You have to practice carefully. I will give nearly 8 to 10 enzyme catalysis reactions. I will give you how to practice. Sucrose will be undergoing hydrolysis in presence of invertase. You will get glucose and fructose. Actually, you have to discuss this one in alcohols preparation from starch. Yes or no? Yes. You see, what is the sucrose formula? C12H22O